Hi everyone, today we are going to learn how to solve a square root equation. So there's two different methods we're going to use, and it depends on how the equation looks. So method one is to isolate the square root completely and then square both sides to undo the square root. So we're going to use this method when we have a single square root like we do in these three equations. Let's do these really quick. So again, I want to isolate this, so I can do that by subtracting 5 from both sides using the inverse operation. So square root of x equals 8. And then now that my square root is isolated, I can undo the square by squaring both sides. So remember, the inverse operation of square rooting is squaring. So x equals 8 squared, and that means that x equals 64. And that's it. All right, let's try part B. So again, we want to isolate square root of x. So first I need to move positive 3 by subtracting 3 from both sides. This leaves us with negative square root of x equals negative 3. So notice the negative is still there. So think of this as negative 1 times square root of x. So I can move the negative using the inverse operation, which is division. So it gives me square root of x equals positive 3. And then inverse operation one more time, square both sides. That's the opposite of square root. X equals 3 squared, so x equals 9. 3 times 3. And last one. So this time I'm going to isolate this entire square root before we square both sides. So we're going to start by doing the opposite of addition, and we're going to subtract 3 from each side. So 4 times the square root of x plus 2 equals 16. And the inverse of multiplication is division. So I'm going to divide both sides by 4. Square root of x plus 2 equals 4. So now my square root is isolated, so I'm ready to square both sides, and that will make my square root sign disappear, leaving me with x plus 2 equals 4 squared, which is 16. But of course, I want x to be completely alone, so I do have one more step in this case. The inverse of addition is subtraction. So we get x equals 14. So sometimes even after you square both sides, you might have 1 or 2 extra steps to finish solving for x. But the big takeaway here is that I don't want you to square both sides until your square root is completely isolated. Okay, go ahead and pause the video and see if you can give these 3 problems a try. Okay, go ahead and check your work. So here we just add 7 to both sides, then square both sides, and we get x equals 100. Here it's 2 steps before we square. We have to subtract 1 and then divide by negative 1. Then we can square both sides, and we get x equals 9. For part C, first subtract 5, then divide by 2. Once our square root is isolated, we can make this disappear by squaring both sides, but you'll see we still have this plus 2 that we need to get rid of using subtraction. So we get x equals 23. So method 2 is when your equation looks something like this. So if you have 2 square roots, so if you have a square root on both sides of your equation, we can't really isolate the square root because there's 2 of them. So what we can do is we can square both sides in our very first step and then finish solving. So when I see something like this, I can clear the square roots again by squaring both sides. And you get 2x minus 1 equals x plus 4. And now I just need to solve for x. So remember, when you have a variable on both sides, pick the smaller one and move it. So I can subtract 1x from each side, and I get x minus 1 equals 4. And then I can add 1 to both sides, and we get x equals 5. So one thing that's a good thing to do with any square root equation, which we can also do with our previous problems, is you might want to check every answer you get. So if you get x equals 5, we can see if it works by substituting it into our original equation. So we can do square root of 2 times 5 minus 1 equals the square root of 5 plus 4. So here we have square root of 10 minus 1 equals the square root of 9, and square root of 9 is equal to the square root of 9. So as soon as you substitute and see that you have a true statement, you know that your answer is correct. So what will happen sometimes, you don't see it in any of these examples, but sometimes you get what's called an extraneous solution, where you did all the steps right and you got an answer, but that answer doesn't actually work. So that can happen with square root equations. So that's why it's always important to check our answers. Okay, so here's our last two. I'd like you to solve these two and double check your answers by substituting them into the original equation. Okay, so go ahead and check your work here. So notice here I squared both sides, and then I picked the smaller variable, which was 3x, and I moved it to the other side using subtraction. Add 7, and you get x equals 8. You can see when I substitute 8 into my original equation, we get a true statement, so I know the answer is true. And for part B, again, square both sides, clearing your square root signs. I picked the smaller variable just to keep it positive, but you could have also subtracted 5x. Either way, you should end up with a fraction as your answer. X equals 1 over 4, which if you substitute here and here, you get square root of 1 over 4 equals square root of 1 over 4, which is a true statement, so our answer is correct. All right, that's all for today.